This lesson is over complex numbers, also known as imaginary numbers. Now, imaginary numbers, those are anything that have a negative under the radical. And before you learned that that was a non-real answer, but now we're going to work with them. So if you have the square root of a negative number, the first thing you need to do is take the negative out by calling it the letter I. So you can get rid of that by calling it the letter I out front. You're saying that it's imaginary. And then the square root of 100 is 10. So you always put the real number in front of the imaginary component. And 10i is the answer to that one. This next one, you take the I out. The square root of 3 doesn't simplify. So here's the order of how you want to write your answer with imaginary. You want to write any whole numbers out front. Actually, you know what? I should more properly say that as integers, but didn't mean to do that. Just a minute. So you're going to write your numbers out front, followed by the letter I, and then followed by any radicals that are in your answer. So that's how you want your answer to look. On the next one, the negative is outside, so that means you're just going to have a negative answer. This is not imaginary here. It just means negative 10, because the square root of 100 is 10. The only time you have an imaginary answer is if radicals underneath, the negative is underneath the radical, such as this. Now this negative, I'm going to take it out and call it the letter I, and then the square root of 121 is 11, so that's 11i. I'm going to simplify this radical first. The square root of 45 is the same as the square root of 9 times 5, and the square root of 9 is 3. So this is 3 times the square root of 5, and then because of this negative here, you have an I. So I'm going to write the answer as 3i times the square root of 5, and that one's finished. Okay, same with this next one, except you have a 9 outside. The square root of 18 is 9 times 2. So that is 2 times the square, the square root of 9 is not 2. The square root of 9 is 3 times the square root of 2. But you already had a 9 out here, so you have to multiply that as well. So I'm going to have 9 times 3 is 27. I'm going to have the I because there's a negative underneath, and then the square root of 2. Now the next one, do not multiply the negative 7 times the negative 21 to get a positive answer here. You have to take the negative out of the radical first. So this is I times the square root of 7 times I times the square root of 21. So what you want to do is outside times outside. So I times I equals I squared. And then I'm not going to actually multiply these together. I'm going to break them down. So 7 and 7 times 3. Because if you have 2 of something, you can take it out of the radical. So I can take because it's like the square root of 49, which is 7. So this is 7i squared times the square root of 3. But there's one other thing. I squared also has a value. So I squared has a value of -1. So if you ever have I squared in the answer, it just changes. It goes away and changes because it's like this. 7 times -1 times the square root of 3. So you get -7 times the square root of 3 for the answer on that one. Okay, for division, again, I'm going to take the I out front first. So square root of 42 over square root of 3. And 42 divided by 3 is 14, I believe. Let me try that. Yes, 14. So I get 42 divided by 3 is 14. So that's 14i is my answer on that one. This next one, since it says add, in the first set of parentheses, there's nothing in front of it, so I just write them down, and I always write it like this. The second set of parentheses has a plus sign, so you can just write it down. So 3 plus 3i. Then you just add up each part. So 9 plus 3 is 12. And -4i plus 3i is a -1i. The 1 is optional there. So 12 minus I is your answer on that one. Okay, the next one, you have a 1. Anytime you have a negative in front of parentheses, it gets distributed. So I'm going to have a negative 14, and then a negative times a positive is a negative, negative 4I. So I get negative 13 minus 4I. And that one's finished. The next one I'm going to multiply and distribute. So 8 times 3, I get 24I minus 16I squared. But we already talked about I squared having a value. So 24I minus 16 times negative 1. So that's going to be 24I plus 16, because a negative times a negative is a positive, 16. Okay, you always want your real component first, so I'm going to rewrite this as 16 plus 24I. Okay, on the next one, I'm going to distribute the square root of 6. The square root of 6 times square root of 6 is the square root of 36, which is 6. And then I have a negative 5I times the square root of 6. Now I have to distribute the 5I. So that's a positive 5I times the square root of 6. And that positive times a negative is a negative 25I squared. Okay, so I've got my 6 here. These cancel. And then the I squared changes the sign out front, so plus 25. So that answer is a real number, 31. The next one, the 6 squared is 36. Then you multiply everything you see together. I have a negative there. 6 times 8 is 48. 48 times 2 is 96. And you have an I. And then you square the last term. Negative 8 times negative 8 is a positive 64. And you've got an I squared. So that's going to be 36 minus 96I minus 64. So 36 minus 64, just putting the real numbers together, is a negative 28 minus 96I. The next one, just like you can't have a square root in the bottom of a fraction, you can't have an I, because it is a square root. It's the square root of negative 1. So you have to multiply the top and the bottom by I. So you get 9I over I squared. But I squared has a value. So you've got 9I over negative 1. And 9 divided by negative 1 is negative 9. So negative 9I is the answer to that one. Number 15, you have to multiply the top and the bottom by the conjugate. So I'm going to multiply the top and the bottom by 3 plus 8I. 3 plus 8I on the denominator. Alright, so let's come out here, because I've got 5 minus I times 3 plus 8I in the numerator. So let's figure that out. 5 times 3 is 15. 5 times 8 is a positive 40, and I have an I there. Then I've got minus 3I minus 8I squared. So 15. 40I take away 3I is a positive 37I, and this becomes a positive 8 because of the I squared that's there. So then 15 plus 8 is 23 plus 37I. That's the answer to my numerator. Now for conjugates, you just basically square each thing. So 3 times 3 is 9. Then a negative times a positive is a negative. 8 times 8 is 64, and you have an I squared. But that changes that to a positive 64. So that's a 73 on the bottom. So that's the answer to that one. Oh, sorry, you have to split those apart. For imaginary numbers, you have to split them apart like this. 23 over 73. And see if you can simplify that. You can't. Plus 37 over 73i. Imaginary components, imaginary answers have to be split apart. They're components. That's why it says a plus bi right here. That's what that means, is to take your fraction and to split it apart.